A couple of you had a question on writing your exponential equations for your logo project, and I kind of wanted to address that here because it's probably the trickiest one to do. If you could go back and look at your parent function on that sheet for an exponential, it looks something like this. And this is the basic form, x minus h plus k. Some of you might notice the b is not there, it's just a. We will have a base when we get to exponentials, but right now just an a. And then the other thing to point out is your locator point, which is 0, 1. And what I want you to notice is that there's an asymptote that runs right along the x-axis. It's preventing it from crossing it. And this locator point is shifted up 1 from what's normal. So we need to keep that into consideration when we are writing our equation. So let's go to the next slide. Let's say you have 2 points, and let's kind of make it a little bit trickier. Say we want to do exponential decay. You want to start here, and you want it to end here. So you want it to make a curve kind of like this, actually, like this, and you'll have to know that it's actually going to keep going until it gets to this asymptote, okay? But the idea here is that it will stop right here. Now, if you want to do that, you're going to have to first, this is going to be your HK, right here. And a lot of you would say that's 1, 2, 3, 4, 5, 5, comma 2. It's actually not. That's not going to be your shift. Your shift is actually going to be down 1. It's going to be right here instead. And the reason for that is, if you think about the last graph, the origin was 1 below this, and that's where we're starting. So you're going to have to bring your HK down 1. So instead of being 5, 1, or 5, 2, it's actually 5, 1. So that's your HK. And then this is going to be your XY, 1, comma 1, 2, 3, 4, 5, it looks like. 1, comma 5. This will be your XY. Okay, so it's still going to go through this point. We just have to make our locator point move down 1. Okay? It's almost like invisible. That's where the asymptote is. Now when we look at the math, go ahead and write out the equation, x minus h plus k. We're going to substitute everything in, so we have 5 equals a. 1 minus h, which is 5, plus k, and k will be 1. Alright, so then we get 5 equals a to the negative 4th plus 1. Now we're solving for 1, or solving for a. Subtract 1. This is going back to Algebra 2 and testing how you know how to deal with exponents. Now you get this weird 4 equals a to the negative 4th. How do we deal with that? Well, we could take the negative 4th root, but that's kind of harder to put in the calculator. We could do that, but that's more challenging than what we can do instead, which is actually the same thing, just in a different form. We're actually going to multiply by negative 1/4, which is the reciprocal. We're going to take it to the exponent. So what this does is it cancels this. And then we have a equals 4 to the negative 1/4. And 4 to the negative 1/4 is equal to 0.707. And you want to be close on this. So that's our a. So now we can write our final equation. Y equals 0.707. Oops. Yep. To the x minus is our h5 plus 1. And if we go back and look at this now, great thing is we have a base that's less than 1. That means it's decay, which is what we wanted. We're shifting 5 to the right and 1 up. And that's exactly where this point is, 5, 1, 1 below. So just remember, kind of the main thing here is you're going to want to shoot 1 below. If the graph went the other way, say it was going like this as an exponential, then instead of shooting 1 below, it's flipped, you're going to shoot 1 above. Okay? Hope that helps.